problems and bit logical and very useful. Just look at the question. F of x be a fourth degree polynomial. Okay. F of x is a polynomial and its degree is 4. So its degree is 4. So surely it involves with x power 4, and they mentioned that coefficient of x power 4 is 1. That means leading coefficient. We say that the coefficient of x power 4, the coefficient of highest degree term is leading coefficient, and that is 1. So and now look at situations. F of minus 1 is equals to minus 1. F of 2 is equals to minus 4. F of minus 3 is equals to minus 9. F of 4 is equals to minus 16. And then we need to find f of 1. Okay? Very simple but bit logical. That's what I am saying. You just have a look. F of minus 1 is equals to minus 1. Okay. F of 2 is equals to minus 4. Okay. F of minus 3 is equals to minus 9. F of 4 is equals to minus 16. First of all, you just identify a rule satisfying these two situations. Minus 1 is minus 1. 2 is minus 4. We know that 4 is 2 square, but minus is attached. For minus 3, this is minus 9. See, we know minus 3 whole square is 9, but minus is attached. F of 4, 4 square is 16, but minus is attached. So when you observe these four situations, what I will write is, therefore, so as given, f of x is equals to minus x square. What is f of x? Minus x square. For x is equals to minus 1, 2, minus 3 and 4. You just look there. For x is equals to minus 1, 2, minus 3 and 4. Only for these four values, f of x is minus x square. Only for these four values. What about for the remaining values? What about for the remaining real values of x? We don't know, because we don't have the function completely. But what we have, we don't have the polynomial completely. But what we have the polynomial values at these four situations. From there we conclude that this is correct only for these four values. For 5, f of 5 is minus 5 square is a wrong idea. But f of 4 is minus 4 square is correct, because they are given. Okay. And now what I do is, that implies, send this minus x square this side. F of x plus x square is equals to 0 for x is equals to minus 1, 2, minus 3, 4. See, f of x plus x square, once think about it. F of x is what? A polynomial. X square is what? A polynomial. So adding these two is again a polynomial. So you just take the sum of this f of x and x square as some other as a polynomial. Since f of x plus x square is a polynomial and this polynomial is 0. This polynomial is 0 at these four numbers. Since this polynomial value is 0 at these four numbers, we call these four numbers as zeros of the polynomial. Okay, so that implies minus 1 comma 2 comma minus 3 comma 4 are zeros of the polynomial f of x plus x square. This f of x plus x square is completely a polynomial. If you feel any confusion, consider it as some g of x or t of x. You just name it with another name. Okay, right. Now since minus 1 is a 0, if you read, as I said, for suppose if you take it like some t of x. Since minus 1 is 0 for this t of x, so t of minus 1 is 0. T of minus 1 0 in the sense minus 1 t of minus 1 0 means by factor theorem x plus 1 is a factor of t of x. Okay, all these are zeros of this polynomial. You may say it as some t of x. From this it is very clear that x plus 1 comma by factor theorem it is clear, x minus 2 comma x plus 3 comma x minus 4 are factors of what? This f of x plus x square, or you may say t of x. All these are factors of that f of x plus x square. Since all these are the factors of f of x plus x square, so f of x plus x square can be written as product of all these things. Okay? So therefore, what we have is, therefore, f of x plus x square is a polynomial, or you may say it as t of x, no problem. Okay? This is a polynomial, and this polynomial has these four factors, and we know the polynomial is of fourth degree. So the product of all these four is simply that. Okay, actually we need to write that f of x plus x square as some a into x plus 1 into x minus 2 into x plus 3 into x minus 4. But as they mentioned, the leading coefficient is 1. Coefficient of x power 4 is 1. This a is again equals to 1. So then simply f of x plus x square is product of these four numbers. So that is f of x plus x square. What we need? We need to find f of 1, right? Now take x is equals to 1. If you take x is equals to 1, what will happen? F of 1 plus 1 square is 1 is equals to 1 plus 1 is 2 into 1 minus 2 is minus 1 into 1 plus 3 is 4 and 1 minus 4 is minus 3. So you just simplify it. 4 2's is 8, 8 3's is 24, minus into minus is plus. This value is 24, send that one that side, you will get that f of 1 is equals to 23. That's the problem. So usually people think that the same rule is true for all the values of x, and they answer in such a way. If anybody asks you f of 5, they say minus 5 square, but it is wrong. If anybody asks you f of 1, they say minus 1 square, but it is wrong. Okay, why? Because these four are correct only for these four values, minus 1, 2, minus 3, 4. Since these four values are making this f of x plus x square as 0, we say by factor theorem, x plus 1, x minus 2, x plus 3 and x minus 4 as factors of this f of x plus x square. Since all these are the factors, you can write it as sum product of all these things into any other thing. They are the factors, but we don't know whether they are only factors or not. So for that, see, we need to multiply all these things with some other factor. But since they mention it as fourth degree, no need to write other factor. Since they mention as leading coefficient as 1, no need to write any constant there. So that's why this is f of x plus x square. Take x is equals to 1 and your f of 1 is 23. Have a look. In the same way we can solve the above problem, okay, which is 10b. So next problem, 10b. Have a look. Now this time g of x is a polynomial and it is given like this. Just for the previous problem 10a, they mentioned that the polynomial is fourth degree. So it directly conveying that the polynomial is sixth degree. And for that problem, they mentioned that coefficient of x power 4 as 1 for 10a. And here it is, they are not mentioning any coefficient for x power 6, which indicates that again coefficient of x power 6 as 1. So the same two conditions which are there for 10a are there for 10b also. Now think about the additional restrictions. See, g of 1 is 1, g of 2 is 2, g of 3 is 3, g of 4 is 4, g of 5 is 5, g of 6 is 6. Then what is g of 7? See, g of 7 is not 7. As a flow, people will say that g of 7 is 7. Okay. See, these 6 conditions are correct only for these 6 numbers. But for the other numbers, the same condition is not correct because it is a polynomial. This is not a pattern problem. Okay. So what it concludes is that g of x is equals to x for x is equals to 1, 2, 3, 4, 5, 6. For these 6 numbers, g of x is equals to x. And what I will write is g of x minus x is equals to 0 for x is equals to 1, 2, 3, 4, 5, 6. See, g of x is a polynomial minus x. So this g of x minus x is again a polynomial, right? This g of x minus x is just a polynomial and that polynomial is equals to 0 for these 6 numbers. Since this is a polynomial and it is 0 for these 6 members. These 6 members are called zeros of the polynomial. Since they are the zeros, by factor theorem we will write that g of x minus x is equals to x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5 into x minus 6. Just because of factor theorem, since they are zeros, all these terms are the factors. Because all these are factors, we don't know whether they are the only factors or not. So this g of x minus x is equals to product of all these things into some q of x. For previous problem also we need to write in such a way, into q of x. But since it is given as 6th degree, if you multiply all these 6 linear factors, it will become of 6th degree only. So this q of x won't be there, there may be a constant. And the coefficient of x power 6 is 1 here. So when you multiply all these things, to make coefficient of x power 6 as 1, you need to take that a again as 1. So this is simply g of x minus x. This is g of x minus x, but what we need? G of 7. Now take x is equals to 7. If you take x is equals to 7, g of 7 minus 7, 7 minus 1, 6, 7 minus 2, 5, 7 minus 3, 4, 7 minus 4, 3, 7 minus 5, 2, 7 minus 6, 1. So all these things is 6 factorial. What it is? 6 factorial is 720, okay? So this is 720. So finally what we have? G of 7 minus 7 is equals to 720 and G of 7 is equals to 727. So our answer for this polynomial is 727. Have a look, okay? Very simple, but some logic is involved. You need to know that logic. Have a look.